Hi, I'm Darren, and I worked with Vaughn and Jeffrey to predict housing prices as part of the group project for CSE 140 at UC Santa Cruz. The goal of the project is pretty simple. Given a Kaggle dataset with images of houses and numerical data about them, predict the price of a given house. And we wanted to build a numerical data model, a CNN for an image model, and then combine them for best results, and we're reporting on progress for the numerical data side of that. We're using a softmax layer to predict price ranges, and we wanted to make sure that every output class has equal representation in the model, so we found the boundary points. And then input of location is very important for predicting the price, and we're given a raw city ID, which is like San Diego is city 61, which is not helpful for our model because you can't correlate that with a price. So we looked into switching that over to the median price of a house in the city, or normalizing the expensiveness of a city. And we found that normalizing the expensiveness of a city actually helped our model become way more accurate. Another important input is square footage, and we tested looking at raw square footage versus normalizing square footage across the entire data set, and we found that normalizing the square footage actually made the model train substantially quicker and made it more accurate in the long run. And then our data was pretty noisy, and there were a lot of entries that didn't fit the price ranges that they were categorized at. So for example, if you have a house that costs $1.5 million but only has one bedroom, it's going to be really hard to use that. So we looked at finding the mean values for each price range and then throwing out all of the houses in that price range that were substantially far away from the mean number of bed, number of bath, and square footage. And so we found that throwing away everything 1 SD or greater actually threw away 42% of our data, which was too much, and throwing away 5 SDs or greater threw out 0% of our data, and the happy median point was about 2%, which had a 45% correct prediction rate and threw out 7% of outliers. So the architecture for our model was we were using deep learning in PyTorch with 4 hidden layers of depth 40 each, and then we're using cross-entropy loss. We're using an atom optimizer for adaptive learning rates. We tested up to 1,000 epochs, and we're using a mini batch size 64. And we use the relative cost of the city, the number of bedrooms, the number of bathrooms, and normalized square footage, and it outputs the price range that it predicts. So for our results, we found through trial and error that our best model had 7 price range classes, and it used the input vector from the previous page, and it was 4 hidden layers deep, 40 nodes per layer. That was from trial and error. And we found that actually after 100 epochs, it started to get less accurate, and it ultimately had 47% correct prediction rate with an off by 1, so it guesses 1 class too high or 1 too low of 37%, so around an over an 85% near guess rate. And results continued. Our model started to show signs of overfitting after 100 epochs. And then no matter the amount of training, the percentage of guesses that were wildly incorrect never decreased from 5%, which leads us to believe that there's a certain number of outliers that we just hadn't identified and would want to throw out. And then as the percentage of correct guesses goes up, the number of off by 1 guesses goes down. And so that's telling us that we can only really accurately predict 80% of our data, and for the other 20% that just is unaffected by training, our model simply doesn't have enough data to pick it up. And so for future work, it would be really helpful to expand the data set to be larger than 15,000 items, because that's not actually that big, and to have our numerical data be more granular. Location, like being next to the beach, would be really important. And then using images from the data set, and for future models, we wanted to use transfer learning, so we test VGG, Inception, AlexNet, and similar, and we'd combine that with our numerical data model. And in terms of direction, it would be great to use the models that we built and predict Airbnb posting prices. Some challenges we faced along the way. Our team got sick a lot including mono and sinus infections, and the campus strikes made it really difficult to get to campus, to go to lecture, to talk to the TAs and whatnot. And then some structural challenges. We used PyTorch instead of Keras, which was difficult because the class is taught in Keras, and we didn't cover CNNs in class until over halfway through the lecture. So there was it took a while to get started. And then we'd like to thank our fabulous TA, Michael, our instructor, Nargis, the Kaggle dataset that we used, and PyTorch and the whole PyTorch community. Thank you.